Welcome to this sixth video about binomial expansion. My website explainingmaths.com is where you will find the other five, and these are past paper questions, so all credit goes to Cambridge examinations. What's going on? It says find the first three terms in the expansion of 2 plus ax to the power 5 in ascending powers of x. Yeah? So if the smallest power of x to the power 0, to the power 1, to the power 2, ascending order. And it's also good to realize that if you would expand the entire thing, you will get 6 terms, because there's always one more than the power, so 5 plus 1 is 6. Okay, it's only to the power of 5, so I like to use Pascal's triangle to do this expansion. So I'm just going to put Pascal's triangle here, the first part of it. There we go, because it's not too much work and it will save me some time in the end. There we go, 1, 5, 10, 10, 5, 1. And what is Pascal's triangle? I've explained it before. This is the addition of the two terms above it. So 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 3 is 6. And you're going to use these numbers to the power of 5. So I do 1, 2, 3, 4, 5 of those rows. And I can use these numbers in a minute. Okay, so the first 3 terms in ascending powers of x. The first term is going to put a 1 there. So that's going to be 5, 0, there we go, 2 to the power 5, and ax to the power 0. So it's 2 to the power 5, ax to the power 0. Now we all realize to the power 0 is 1, but I still like to write it down, because it reminds me that 5 plus 0 has to be 5, and in a minute 4 plus 1 has to be 5. The sum of these powers always has to be 5. Okay, I'm using Pascal's triangle to work this part out, so that is 1. Yeah, 1 times 2 to the power 5 is 32, and ax to the power 0 is also 1, so that first term is 32. Good, moving on to the second term, so that will be 5, 1, 2 to the power 4, 1 less ax to the power 1, 1 more, again the sum is 5. 5, 1, I'm going to use this number, 5, so that is going to be 5 times 2 to the power 4 is 16, and ax to the power 1 is ax, so that will be 80 ax, and term number 3, 5, 2, 2 to the power 3, 1 less ax to the power 2, 1 more, 5, 2 is 10, so I'm going to get 10 times 2 to the power 3 times, now make sure you do a squared, x squared, everything squared, so that's going to be 80 a squared, x squared. Yeah, so those are the first 3 terms. You might want to write it down then horizontally, so 32, have perhaps an arrow, 32 plus 80 ax, no, not plus 80 ax, yes, plus 80 ax, plus, sorry, I'm confused there, plus again 80 a squared, x squared. I'm just going to do plus dot 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 dot, because I realize these are only the first 3 terms. In total there will be 6. Okay, moving on to the second part, I'll do that in red. So I, there we go. Given that the coefficient of x squared in the expansion of 1 plus 2x times 2 plus ax to the power 5 is 240, find the possible values of a. So values implies more than 1, so realize that, and see the connection between part I and II. So I'm going to rewrite this like you do every time. Instead of 2 plus ax to the power 5, so that first part stays the same, I'm going to write that expansion of part I. So 32 plus 80 ax plus 80 a squared x squared plus, I'm just going to put those dots there again. There we go. Okay, so if I expand this, I'm interested in the term in x to the power 2 in x squared. Now when am I going to get x squared? Well, 1 times 32 is not going to give me a term in x squared. 1 times 80ax, also not. But 1 times the term in x squared, 80a squared, x squared, is going to give me a term in x squared, which is 80 a squared x squared. Okay, now if I would continue all those other terms, the next term is going to be x to the power 3, x to the power 4. So 1 times x to the power 3 is not going to give me a term in x to the power 2, and the same for all those other terms. So that's it for x to the power 2 multiplied by 1. But I'm going to get another term in x to the power 2 because I have here 2x. And 2x times 32 is 64x, not x to the power 2. However, there we go, 2x times 80ax is going to give me a term in x to the power 2 because that will be 160ax to the power 2. Fantastic. And the same for 2x times this term is going to be x to the power 3. 2x times that other term is going to be x to the power 4, not x to the power 2. Okay, so the coefficient of that is 240. So if I would combine those like terms, I would get 80a squared plus 160a x squared. Yeah, and yeah, that's the combination. If I would combine the like terms, and the coefficient apparently is 240. So I can now say that 80a squared plus 160a equals 240. And they already told me find the values of a, and indeed a quadratic equation, so probably 2 values. Make your life easy, divide everything by 10. So you see 8, 16, 24. And then you see, oh, I can also divide everything by 8. So I get a squared divided by 8 plus 2a minus 3 equals 0. So I also already moved the 3, 24 divided by 8, to the other side. Because when we're solving quadratics, we equal it to 0. You can use the formula, but easier is to factorize, or easier, yeah, quicker anyway. So that's going to be multiplied minus 3 if you add 2. So plus 3. And, I say x now all of a sudden, it should be a. Apologies, minus 1 equals 0. So I will say a now minus 3, or a equals 1. The ZPP, the zero product property. Fantastic. Check my website explainingmaths.com for all my free videos. Like and share if it was useful. I wish you a very pleasant day. Bye bye.